we'll continue solving IP past papers, questions, paper 1. Now we reach question 21 from the document. Here we have third harmonic standing wave. Third harmonic, it means we have 3 anti-node. Wavelength lambda. The distance from here till here is half wavelength. Between 2 nodes, half wavelength. So the distance from here till here, this is full wavelength. So this distance is 0.8 meter. You have 2 points on the wave that are separated by distance 0.6 meters. So if I take this point and 0.6, it will be here. Here. This is node, and this one is anti-node. So the phase difference completely out of phase. By how much out of phase? By pi radian. Okay. Now 22, we have a particle moving. In a circle, completes 5 revolutions in 3 seconds. What is the frequency? This is circular motion, but as we said, circular motion is related to waves. So frequency is the number of oscillation or revolution per second. So divided by time. Number of revolution is 5. Time is 3, so it will be 3 over 5 hertz. Okay, I'm going to question 24. The graph shows the variation of the displacement y of a medium with distance x with time for a traveling wave. Okay, so here we have displacement with distance, displacement with time. What is the speed of the wave? This is the question. What is the speed of the wave? Now to find the speed, it's distance over time, wavelength divided by the period. Now wavelength is from the first graph. Wavelength is the distance between 2 points that are in phase, 2 consecutive points are in phase, or they're doing the same thing. So if I take a crest and crest, these 2 points, consecutive points in phase, this distance here is 8. So it's 8 meter, the unit meter, 8 meter. Divided by 8 meter. Divided by the period from the second graph. The period, now this point here is oscillating up, this is down, this is oscillating up, 2 points in phase, 2 consecutive points, they're doing the same thing or in phase. So this is what time, 10 millisecond, that means 10 times 10 to the power negative 3 second. So this is the answer. Yeah. So the answer will be 800 meter per second. 800 meter per second, and this is G. Okay, now next question. We have a double slit experiment. A source of monochromatic light. Monochromatic, it means one light with same frequency. So we have red light is incident on slits S1 and S2. So here we have double slit. The distance between them is small d. And screen is located at distance x. Here we have a screen at distance x from the slits. Here we have pattern with fringe spacing y between them. So this is the y is the distance between the central maximum of the bright fringes and the first bright fringe, or between two maximum. Now, three changes are possible. Now, what is the formula for this one? Here we have a light lambda, so it will be lambda over d equals y over x, y over x. Now, I need to write formula for y. Which changes will cause a decrease in the fringe spacing y? So y equal cross multiplication lambda times x divided by d. I need to decrease y. If I want to decrease y, I have to decrease lambda and increase the spacing. So first one, increasing the distance is wrong. Okay, I have to decrease the distance, not increasing it. Increasing d, yes. Using green monochromatic light instead of red, also yes, because lambda for green is less than lambda for red. Lambda for red is long compared to the green light. Compared to the green light, lambda here is less. So the correct answer is C. That second answer and the third answer. Okay. Now 26. We have two strings of length L1 and L2 are fixed at both ends. The wave speed is the same for both strings. They both vibrate at the same frequency. L1 vibrate at the first harmonic, L2 vibrate at the third harmonic. Okay, so I need to find lambda. This is lambda 1 over lambda 3. Now, lambda will be 2L over N. This is general formula. Lambda 1 is 2L. N is 1. Lambda 3 is 2L over 3. So I need lambda 1 over lambda 3. It will be 2L divided by 2L over 3. 2L over 3. I'll put the 3 on the top. This and this, they cancel. So the answer is D. '27. So here, this is this. How did I get it again? It's 2L divided by 2L over 3. When you divide, you flip and you make it multiplication. So it will be 2L, 3 over 2L. 2L and 2L, they cancel out. Now 27. Okay. 27, L is a point source of light. The intensity of light at distance 2x from L is I. What is the intensity? So this one, I'm going to call it I1 is I. The distance D1 is 2x. Now I need the intensity I2, how much? At distance D2 equals 3x. At distance 3x. Now we know intensity is inversely proportional with a distance. I is inversely proportional with D. It's power over area. I, intensity, it's power over area. Area. 4 pi times r square, or a distance square. So I and distance, they inversely proportional. That means I can write the formula in this way. I2 over I1 equals D1 square over D2 square. Now substitute I2, I need to find it out. I1 is I equals D1 is 2x squared, it will become 4x squared. D2, 3x squared, so it will become 9x squared. X squared and x squared, they cancel out. So I2 over I1, I2 over I will be 4 over 9. So I need I2, it will be 4 over 9, I, 4 over 9, I, 4 over 9, I. So I2, it's 4 over 9, I. Okay. Next question. 28. 28, you have X and Y are two coherent sources of waves. The phase difference between them is 0. Okay. The phase difference between them is 0. So the angle cosine 0 to be 1. Okay. The intensity at P due to X and Y separately is I. The wavelength of each wave is point. So this is lambda. The question is, what is the resultant intensity? What is the resultant intensity? If you remember the formula, I will equal the first intensity plus the second intensity plus 2 square root I1 times I2 cosine the angle. Now both of them, they have the same intensity I, so it will be I plus 2 square root I times I, it will be I squared cosine the angle 0 degree. Cosine 0 is 1. So I plus I is 2I plus 2I, because square root of I squared will cancel with the square root, so I'll have 2I. 2 plus 2, so the answer is 4I. 4I. Okay. Very 29 is easy question. We'll go to 30. 30, we have first harmonic standing wave is formed on a vertical string of length L, of length 3 meter, using a vibration generator. The boundary condition for this string are at fixed. It's fixed at one boundary and 3 at the other. Fixed at one and 3 at the other. So at the fixed one, we will have node. This is the first harmonic, and this will have antinode. Lambda will be 4L over N. So the frequency, it's velocity over lambda, V over lambda. So V divided by 4L, N here, we'll put it here. Now, what is the speed of the wave, the generated frequency? So this is the frequency of the first harmonic, 300. First harmonic N equals 1. So if I need the velocity, just do cross multiplication. V will be 4L times. Now 4. So V will be 4. L is 3 times 300. And you should get 3.6 kilometer per second. Kilometer per second. Okay, now question 31. We have two traveling waves are moving through a medium. The diagram shows for a point in a medium, the vibration with time t of the displacement d of each wave. So we have displacement in millimeter versus time in millisecond for the two waves. The wave, the leading wave is the wave that you see, it's crest first. So this is the first wave, this one, and the red one is the second wave. So the blue one is the leader and the other one is the laggard. Okay. What is the phase difference between them? We can look at it. This one is here. It goes to here. It's half lambda. That means pi over 2. Or this one is actually sine the angle. Start from 0 is sine, and this one is cosine. The phase difference between sine and cosine is pi over 2. Or this crest, it moves to here. So from here till here, this is quarter lambda. So that means pi over 2. Now, when t equal 2, okay. When t equals 2 millisecond here. What is the phase difference? Okay, and what is the resultant displacement? The resultant displacement of the wave. Now, the resultant displacement, the first, this wave here, it has displacement up, it's around 1. So this is y1 equals 1. And the other one down, I'm going to use different color. This one here. Okay. So the displacement here, it's this point, it's around 2, 4, it's around negative 1.6. Negative 1.6. So this is y2. So resultant displacement is y1 plus y2. So it will be 1 minus 1.6. So it will give us negative 0.6 meter. Negative 0.6 meter. And so the correct answer is D. Phase difference is 90 degrees, pi over 2. And the resultant displacement is negative 6. Negative 6. Okay. Last question, and then we'll continue in the next video the rest of the questions. Last question I'm going to solve is question number. You see, there is, I'm not leaving this question. That means that they're not important. No, you have to study them. I'm leaving them because they're easy. You can find the answer quickly. It's you don't need any calculation there. There is no calculation. If the question is tricky, I would explain it. Now 35. 35. We have two sound waves from a point source on the ground travel through the ground to a detector. The speed of one wave is 75 kilometers per second. The speed of the other wave is 5 kilometers per second. The waves arrive at the detector 50 seconds apart. So this is delta t. Delta t. Delta t, the difference between time is 15 seconds. 15 seconds. Now I need to find a distance. What is the distance? Distance, it's time, sorry. Distance is velocity times time. So time is the distance time is distance divided by the velocity. So if I'm going to use this one, I have a time. The first time, I don't know the first distance. They have the same distance because they move the same distance. So I'm going to call this distance d divided by the velocity. The first velocity, I have 5. The second velocity, sorry, this is t2 minus t1, t2 minus t1, 5. And the second time, the first time, same distance, the first time, 7.5. 7.5. I'm not going to change anything now. Now, what I'm going to do, this will equal what? 50m. To do this calculation, they have to have the same denominator. So I'm going here to multiply by 7.5 and this one by 5. If you multiply the denominator by a number, you have to go to the numerator and multiply it by the same number, 7.5, and here times 5. Here, both sides. So this one I'm going to multiply by 5 times 5 times 7.5. Okay. Do cross. So here we have 7.5 d minus 5 d will equal, I multiply both sides, 5 times 7.5 to get rid of this number. So it will be 15 times 5 times 7.5. I get rid of this. Either you do cross multiplication or you just multiply both sides by 5 times 7.5 to get rid of the denominator. Okay? If you calculate this one and you simplify it, d, you should get the distance is 225 kilometers. So 225. Okay, I'll stop here. I'll continue.